Dear students, I would like to present to you an important theorem pertaining to the binomial distribution. The statement of the theorem is as follows. Let capital X1, capital X2, so on up to capital Xm be independent random variables such that xi has the binomial bnip distribution where I itself is equal to 1, 2, so on up to m. Let capital Y represent summation xi where I goes from 1 to m. Then Y has a binomial distribution given by B summation ni where I goes from 1 to m, comma P. ये जो कुछ मैंने कहा, it is not as difficult as you might think. अगर हम इसको आसान लफ्जों में ये बात करना चाहें, तो हम ये कह सकते हैं कि the sum of m independent binomial random variables with the same value of p, this sum is also a binomial random variable. Let me try to prove this with the help of the MGF, the moment generating function of the binomial distribution. Dear students, as you already know, in general, the MGF of a binomial random variable capital X is given by MT, or we can write better MXT, where X is written in the subscript to indicate that we are talking about the random variable X. So MXT is equal to Q plus P e raised to T, this whole thing raised to N, where of course Q itself is equal to 1 minus P. Now this is the general expression for the MGF of a binomial random variable X. In our case, the theorem that I'm wanting to prove, we are having m binomial random variables, x1, x2, so on up to xm. So हम इस तरह भी कह सकते हैं कि we are having m binomial random variables xi, where I itself is 1, 2, so on up to m. और ये जो बात important है इसके अंदर, जैसे मैंने पहले कहा कि all of these xi's, they have the same value of p. So p1, p2, p3, so on up to pm, they're all equal to p. They are all equal to each other, and that number is being denoted by p. In this case, my dear students, what will be the algebraic expression of the MGF of the ith variable xi? देखिए, पहले हमारे पास था mxt और एक्सप्रेशन था q plus p e raised to t whole raised to n. अब हमारे पास होगा mxi t और उसका जो एक्सप्रेशन होगा that will be q plus p e raised to t whole raised to ni. बात ये है कि हमने ये कहा था ना कि p is constant, लेकिन हमने ये तो नहीं कहा कि n is also constant. So that's why we must realize that for the different variables x1, x2, so on up to xm, n is changeable, and so we have for the first one that parameter is n1, for the second variable x2 that parameter is n2, and so on. So for the ith one it is ni. If you've got this, then the next point, my dear students, is that the MGF of the sum of n independent variables is equal to the product of their MGFs. I think you have already studied this fact. Let me say it again. If the variables x1, x2, so on are independent, then the MGF of their sum is equal to the product of their MGFs. So in this case, what do we get? Sum जो है उसको हमने किससे denote किया हुआ है? As I said earlier, y is representing summation xi, I going from 1 to m. So therefore, this new variable is y. तो अब अगर हम कह रहे हैं MGF of the sum, so दूसरे लफ्जों में we are talking about the MGF of y. So according to this point that it is equal to the product of the individual MGFs, what do I get? I get MYT is equal to pi, I going from 1 to m, q plus p e raised to t whole raised to ni. आप जानते ही हैं कि जिस तरह summation sign, वो जो capital sigma है, that represents summation. इसी तरह capital pi, that represents product. अगर आप इसको खोल के लिखना चाहें तो कैसे लिखेंगे? Of course, it will be equal to q plus p e raised to t whole raised to n1 multiplied by q plus p e raised to t whole raised to n2 multiplied by q plus p e raised to t whole raised to n3 multiplied by so on, so on, so on, and in the end multiplied by q plus p e raised to t whole raised to nm. अब ये जो इतना लंबा एक्सप्रेशन मैंने आपके सामने रख दिया, स्टूडेंट्स, डोंट यू सी दैट द पावर्स विल बी एडेड? ऑफ कोर्स, अगर बेस कॉमन है तो पावर्स तो ऐड हो जाएंगी. सो व्हाट इज दिस होल थिंग इक्वल टू? इट इज q प्लस p e raised to t whole raised to summation ni, where I goes from 1 to m. Obviously, summation ni वही चीज है, n1 plus n2 plus n3 so on up to plus nm. अब जो ये एक्सप्रेशन आ गया है हमारे पास, my dear students, please have a very careful and close look at it. हमारे पास क्या चीज है? MYT is equal to q plus p e raised to t whole raised to summation ni. आप देख नहीं रहे कि ये एग्जैक्ट वही पैटर्न है, वही एक्सप्रेशन है जो कि बाइनोमियल डिस्ट्रीब्यूशन के MGF का होता है. The only thing is that the power is not n, but it is summation ni. This is why we can say that y, or in other words, summation xi, has a binomial distribution with parameters summation ni and the other one p. This is the proof of this interesting and important theorem.